Well, hi, good morning. Thank you so much for joining me in my shop and spending some of your time with me. Today is January 16th, waiting for more snow to come. It's been a busy day here already. It's a little late in the morning, so I'm off to a bit of a late start. Yesterday I performed the AM alignment, and at the very end I discovered the pointer was not in the right spot on the string. So that requires a little bit of adjustment to correct it. No, it's not a big deal at all. What's really in front of me now is the FM alignment process, which is much more involved than an AM alignment process. So I'm probably going to get to that today, but I don't know because we're expecting a delivery here today, and when that happens, I will have to deal with that. I'm getting a new small fridge today. So, okay. AM alignment. So let me warm everything up and we'll complete the AM alignment and then take a look at the FM alignment, and at the very least try to get all the equipment set up appropriately to perform the alignment. Okay, step one is to get the pointer in the right starting position. Now I did go through the manual and I did find a piece about how to put the pointer on the string, and sure enough it identifies this diamond as the pointer starting spot, and right now we are not there, so I'm going to try to push this pointer over this way. Now just a little trick here I'm happy to share. If let's pretend this is the string here and the pointer is sitting about here and you want to move it this way, so you might think you better grab the string, hold it still, and pull the pointer this way, but in fact that's a very difficult way of doing it. Counterintuitive is the idea that here's the pointer, you want to move it this way, you grab the string here and you start pushing, and what happens is the string will go slack between where you fixed it, where you're holding it, and the slider part on the pointer, and when the slack happens it'll go right through the gripping part of the pointer, and the pointer will lose its grip and you'll be able to slide it along the string. So counterintuitive, you push it towards where you fixed the string. Okay. Now, so I'm going to fix the string here by just pinching it so it doesn't move. And I'm just going to push the pointer along the string here, like so. Wasn't that easy. Now we'll just go to the other end. It goes over by about the same amount. So that's the way you would expect an engineer or designer to arrange it. But the most important thing is that it comes back to this diamond here. Bingo, right on the diamond. Okay, so I'm going to let this warm up a little longer, and then we'll just correct the AM alignment. Won't take long. Then we'll study up on the FM side of things. Okay, ready to start here. First of all, I have the audio from the radio turned right down on my soundboard over yonder. I'm just going to pull this out and just listen to hear if you can hear a change. So even with the volume turned down over yonder, there's still a fair bit of noise coming through. Just keep that in mind. A little bit of noise. Oh, no, turn this way. So I have the radio tuned to 1400 exactly. Yep. And I have my signal generator tuned to 1400, just a hair below right now. So I'm going to turn the sound up over here. Okay, let's see if we can just turn it here. Well, what frequency is this thing actually receiving when it shows 1400? Oh, not going to receive anything at this rate. Let's try this. It's not much better. What's going on? Way up here. Yeah, no modulation. There we are. Wow! How did it get way up there? Oh, that's right, I've moved the pointer. I moved the pointer. Exactly, that's why I'm doing this. Okay, now we got to drag that all the way down to 1400. Oh boy, oh boy. So let me get my tool here. So the procedure I follow, I call it hopscotching. I don't know why I call it that, but I do. Oh yeah, this screw is open wide. I remember complaining about that. Let's close it. Very hard to keep the screwdriver in place here. Where are we now? That's it? Thought we'd be way down here by now. Okay, I'm going to set this down here. And keep closing this thing until we go across it. Come on. There it is. Good. And now the capacitor here is, you know, that raises an interesting question. In a number of these radios, when I've aligned them, I've found I've had to have a certain trimmer wide open, and I never see the peak. It's just getting better, but then the capacitor never crosses the peak. I wonder, one way to compensate for that is to fool around with the IF frequency and shift it off, and try to bring things in better, if you know what I mean. Another way would be to move the pointer on the string, potentially, and that'll cause an adjustment here. Very interesting stuff. Okay. Okay, that just fell off over there. Now we're going to watch the meter over here. Let me set. This is only. We're not even at 1400 yet. Come on, man. Pay attention to what you're doing. Excuse me. Okay, let's make that meter go up. Why is this so difficult here? There we are. Okay. Now we were supposed to go to 600. Okay, 600. No parallax error. Okay, we're on 600. 600. Close. Very close. Inductor and meter. Meter. Yeah, really close. Did I put this on? This is on 600. That's on 600, so okay, I go back up. Because I adjusted the low end just a little bit, I probably didn't do much to the upper end here at all. Let's find out. So 1400, no parallax error. 1400. What do you say? That's pretty darn close. Okay, so now we need to do the other two, the intermediate and the antenna stage and intermediate stage adjustments. Not with this. They all look alike. There we go. Okay, now eye on the meter. See, this is wide open here. It's another capacitor that was wide open. Oh, what's happening? It sounds like it's getting louder while the meter goes down. Slight peak there. Doesn't really, oops, not really showing a peak. That's tight. Yeah, I guess it is. There. Very good. Okay, and now the last one. Wrong one, Jim. Whew. I almost made the classic alignment mistake of turning the wrong screw. Okay, this one here again. Up, 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 down. Good show. Okay. That be the AM alignment. We'll make a quick check. And switch from the signal generator to antenna. Don't think the antenna is switched on down here, but there'll still be some signal in this loop. I hope. What is that? Weird sound. Is that coming out of the radio? Or comes that mechanical? Oh, it's just mechanical stuff. A little bit of lubrication needed here. Let me turn the volume back up. That would be 1010. $865. Remember, I'm not really boosting the antenna very well. In fact, am I boosting it at all? Not helping. That is not helping. This is a directional thing, so... Well, that's fantastic reception here in the shot. Hamilton, let's check direction. This way. 740.
Interesting, and maybe you want to check it out. Coming up, the number 9 song.
The number 9 song. 680. There's a noise signal right on 680. You can hear it, obviously. Every time I try that station, we get the noise. 640. So can you see that there's a little notation just above my finger there? It's right there, and the same notation is right over here. It says CD. That stands for Civil Defense. This is a system the Americans had put in place in their AM radios to mark every AM radio with where you would tune just before the nuclear bomb blew your head off. So that's what that is. It happens to be 640. I don't know if that system still works. Do they still do that in the States? They still... Very good. Okay. We're in good shape here. So, next thing is FM alignment. So we're going to do some reading before starting that up, that's for sure. So, but first, coffee time, absolutely. So as I said before, probably the most I'll do today is just get the FM equipment set up and get it all ready to go to do an alignment tomorrow. But we'll see. We'll see how it goes. But right now, coffee is king. Okay, so we're going to take a look at the FM alignment procedure here, and I'm just going to comment on it. So this is my FM stereo FM signal simulator, WR52A, sometimes called a wobbler. Uses 60 cycles to produce a wobble in the FM frequency, or modulation, if you like, FM modulation. The thing about this guy is he's fixed at 100 megacycles. It just produces one signal at 100 megacycles. Produces all the other signals you might want to help align an FM radio. Now let's look at the instructions here. So I have done a number of FM radios. I found them all to be difficult and challenging. And so now this is the complete FM alignment procedure using a sweep generator, marker generator, and oscilloscope. I don't have a marker generator. Well, I have another way of doing that, but it's clumsy, with another signal generator, but it is clumsy. So just roughly looking at what they've got here, they've got different displays on your scope from the sweep generator, and different ways of hooking stuff up, and different frequencies being used, same frequency being used, and what it is you're adjusting to achieve this look, this kind of thing here. Let's see, connect sweep generator, pin 1V9, pin 1V8, pin 1V7, pin 1V9. That's all easily done. Sweep generator, so 10.7, doesn't look to me like they're talking about, well, it must be sweeping. It must be sweeping to do this. So as I said, my sweep generator is stuck at 100 megahertz, not at 10. Now there is an output from my sweep generator called composite signal and audio, but I don't think that's going to do it either. So I guess what they're showing here is the marker is right here. This little blip you see. So I think that's really what's going on here. Now I think I can achieve this by using the equipment I got the way it's intended to be used, and not exactly following these instructions. Because I can't do this. Okay, so that's not so good. And what are you actually measuring? Maximum measuring oscilloscope to be connected across 6.8 resistor, a center post to ground. Okay, and this is very important. Disconnect the positive lead of C60. C60 is probably a small electrolytic capacitor in the FM detector, and if you leave it in place, you'll have a hard time getting these kinds of shapes. But if you take it out, you can get these kinds of shapes. So that's why they're saying take it out of the circuit. Probably I'm on my way to replacing this anyway. Typically in an FM receiver of this age, this particular capacitor that you find in the detector is almost always needs to be replaced. That's what I've found. You get a pretty good improvement when you replace that. Okay, so I can probably achieve these somehow. Reconnect the lead, tune a pointer to 98, sweep generator to 98. Can't do that, so I'm stuck at 100. Marker generator 10.7. So you're still looking, I guess, in the IF, the FM IF. Why are you doing this? 98 and then 106, which I can't do. Why do this? Pin through resistor, blah blah. Top and bottom of some slugs located on pre-wired front end. Adjust C39 located on top of pre-wired front end. Okay, yeah. Yeah. Let's look at this schematic here for a sec. That would be part of a sec. So here's the detector and some of the places we need to make connections. Here's the C60. And that almost certainly has to be replaced, or I should replace. Something I haven't done, and let's do it right now. I did not look at how these tubes are biased. It looks like cathode bias here, and we have a capacitor here blocking. Not blocking much. Let's go over this. Look at this one here. So this grid is getting a voltage supply, hopping. This is the magic eye here. Why? Oh. So this must be self-biasing, this tube. And this one's probably the same here, self-biasing again. So we should see a fairly large resistor. We have 5.6 megohms. That's a big one there. So this is a self-biasing tube, and this guy doesn't appear to be done the same, but where's the rest of the schematic? I have to look at another page here. Don't really know for sure what they're doing. Let's look at the this is the same thing over here. Again, 820K, it's probably self-biasing this tube. This one's got a cathode resistor in it with a bypass. And these RF tubes, I don't know what to say. This almost looks like a, I can't think of the word for it now. And not, again, another self-biasing methodology here. Not sure. Not sure. Okay. So, getting back to the instructions once again here. So, the first thing I would try to do is put the sweep generator right into the antenna and just tune in the sweep generator and just kind of see what we get, what we can get on the scope. Where would I be hooking the scope up? Across a 6-point K resistor R36 center post ground, center post R36. Are there diagrams that show where these things are? R36, probably in the detector circuit. R11. Wow, where's 36? Oh, we're in the FM radio. Right, down here. R33, 34, 36. There it is. R36. So you're reading 1/2. There's another similar resistor here, so you're kind of looking at 1/2. Okay, we can probably find this, and put the scope across this. Oh, I got lots of stuff to set up here. Okay, coffee time. Okay, so step one in using this device is I have to get a wobbler set up to wobble my scope. What I mean by that is I need a 60 cycle signal to sweep the scope this way eventually. Right now I've got the scope sweep just running normally, and you can see the sine wave here. So this sine wave is coming from this transformer you see here. This is just a random transformer I have. Outputs 24 volts or something like that, and I just simply set my scope to accommodate it. Now I'm just going to move the scope control all the way here. So now the input here is causing a sweep to go like this. The input here will cause the vertical display. We'll make the sweep a little bigger there. Now this is not your normal sweep by any means. If we could tip this up like that, you'd see it's a circle. So what's going on here is this is going back and forth. It's dwelling at the ends. That's why the ends are a touch brighter, which you can't really see from way back there. Come on and have a look here. And you see the ends are just a little brighter, and that's because the sweep is delayed here, because you can picture, a circle, how much time is spent out here in the circle. So a little brighter on the ends and a little weaker in the middle. And the other thing is it's not blanked, so when it sweeps back, it just sweeps along the scope again. It just sweeps on the screen. So so that's why it's called a wobbler, because it's kind of wobbling. That's a British term. I think late in the evening a lot of British people are wobbling around the streets. Okay, so that's good now. So that's the sweep setup. It's not supplied from this machine at all. That's the whole idea, is that this thing's working off the 60 hertz, and this is working off the 60 hertz, same 60 hertz, same power, and that's how they end up coordinated. That's the whole idea there. Okay, so that's one step done. Next step is to take the output from here. This is the output here. Just here, go up in the sky a little bit here. This is the output, and we're going to hook that up to the antenna. Oh, which incidentally, whoever did the antenna, and I haven't changed it, didn't do it right. So we're going to take this off. So this is actually an FM antenna lead here. These two things, and they should have been on the FM screws only. You have one on the ground screw. I'm sure that would not work out well. take the output from the wobbler signal simulator. They don't even call it a signal generator. For some reason they call it a simulator. I'm going to stick them on here. Very good. Meanwhile, there's a ton of activity going on down below. As I try to decide which wire should I bite. No, don't bite the ones with 120 volts on them. Okay, don't bite those ones. Okay, so antenna connection is done. Next thing is, I still have the AVC connection here. I'm going to take it off because it's just unnecessary. Wire on the bench right now. Very good. We should plug this into the FM so we can hear some stuff. Did I leave the volume up? No. Okay, or you might have heard that. This is the ground to the voltmeter. We don't need that anymore. On there. Put that guy there. And I think we're ready to go. So you want to tune this guy to around 100. Right on 100 actually. And we'll see what we get out of it. Now, my signal simulator can do a stereo signal, of course, but we don't want that. We want mono, and we do not want the 19 kilohertz carrier on. Not that it really matters. Sub-carrier. I'm going to turn this on, let it start warming up. Maybe you see the little red light came on. And I think we just leave it like that. RF sweep setting here. We'll get to that in a minute. You can set the deviation with I believe it's this control. So normal deviation signal, FM signal, maximum deviation 75 kilohertz. We'll stick it just a little bit below there. And go drink coffee. Wow, we're just about ready to go here on an experimental basis. Okay, here we go. I think I got everything set up. Oh, I forgot to put the special camera on here. Well, just watch from a distance right now. I'll just turn this up a little brighter. Okay, don't know what to expect up here. Nothing. You can't expect anything. I've got nothing connected here, Jim. Jim. Okay, gotta stop. I left something out here. Well, I hunted through the manual until I found R36. There it is. Now, luckily in this manual, at each paragraph, they write the component that you are installing. This is the installation instructions. So R36, connect the 6800 half-watt resistor lug 2 of tube socket 10 to lug 1 of control D. Lug 2. Okay, so so spent some time studying this and I found it. Here it is. Lug 2 of V10 6800 to D. There it is. So this is the resistor across which I am supposed to read this voltage. So look. So see this wire connected through here. That's a ground. So this is grounded. There's a wire coming up through here. Wow. Where is it connecting? Looks like it's connecting here. So it would be 6800 from pin 2 to a grounded pin. This is just an opportunity to reach a grounded pin. Look, there's another 6800. Well, there's two of them, of course. They're balanced. Let's look at the schematic. We'll see where the 6800 is. I think I know. And we're on the positive end of this. You could probably do this on either end, on either of these resistors, I would guess. Want to look at the schematic at this location. Okay, I think I can just go like that. So here it is. There's the 6.8K right there, and there's the other one right there. There's the grounded spot, and here's the capacitor with the positive end hooked up here. So I got R36. So it all adds up nicely. Do I have to connect this to do this test? Let's find this and this in the back of the radio now. Okay, it wasn't too hard to find. So this is control D. This is the terminal on it. You can see two identical resistors here, 6800, both of these. You can see this gray wire going down to this terminal and then into the center pin where it's grounded. So this is all matching exactly. And there's the the positive end of the capacitor here. This is the capacitor I'll probably want to replace, but this is a nice looking one here. So, but in a lot of radios, this guy has to go. A lot of FM radios of this age. So I need to connect across here to ground. Okay, I can do that. So we'll put this on the ground. This will be the... No, I have another ground already connected here through this. So put this on the ground connection. And this is not on, by the way. Such a way it won't come off. And then we're going to set this. Let's do it this way, like so. Fortunately, it's hanging out. Radio's got to be on its side now. Okay, that's going to give us some vertical action on the oscilloscope. Move this over here. Okay, is everything safe? Now I think we're ready to go. So, headphones. So, we're just doing this to see what happens. I'm not suggesting I got this connected up in such a way that everything's ready to go. Not at all. But let's just see what happens here. Okay. Just get rid of that. Just taking a moment here to make sure everything's good. Yeah, I think so. Power on. Dim bulbs first, just in case. All is well. Here we go. Now, I think we're on AM here. That's a good place to start. AM. And we'll give it a couple of minutes to warm up. Ooh, I can hear something already. So even though the volume is turned to 0 on my volume on my control panel over here, it's still some audio leaking through. Let's turn it up a bit. There we are. Yeah. Sounds like an AM radio. Yeah. Okay, so everything's working just as it was. We'll switch now to FM. So down on the volume just in case. And you know what? I switched this to FM. How come we were hearing that? I don't know. Okay, no answer. No answer comes the reply. We'll switch over to FM. That's FM there. FM. Turn it up now. Ooh. You know what? That tone, I think that tone might be coming out of here. Yep. Okay. I think I can just turn the deviation down and we won't hear it anymore. Okay, so the radio was already receiving the FM signal, by the way. That's what we were hearing. So why did I turn it down? So here, we're good. Okay, turn it back up, Jen. Turn the deviation back up. Turn the frequency down. It's more pleasant to listen to 1,000 hertz. There we are. Tune the radio and see. So characteristically, when you tune an FM signal, you get 3 spots. You get a spot, you get the real McCoy, and then you get a spot above. So you usually hear 3 things. At least I do. 1, 2, 3. Get the guy in the middle. Sorry about that. I lose control of the volumes when I'm doing this. Keep that from going so high. Okay, now what about the scope? I don't see anything happening on the scope here. Maybe it's because I've got this not nearly sensitive enough. Oh my gosh, that's maximum sensitivity. We're on DC here, which should be okay. Nothing? Nothing? So this should be doing something. We got nothing. How do we get nothing out of this? So this is why I said today probably we'll just get this thing set up because there's always trouble with this. Why not? Ooh, what was that? What about this control back here? What is this anyway? This is FM level. Well, it's just a ground. Oh, wait a minute. Okay, I got this hooked from ground to ground. Here's my mistake right here. Okay, make this less sensitive. This should be on the other end of this resistor. It should be. And which one? The one that's hooked up to the positive end. So we can go right here. Okay, now we should see some action here. Show me some action. Oh, I got a DC voltage pushing it up, so I'm going to flip this to AC. Put it back in the middle. You can't see it. Well, we got something. So I'm going to set up a camera there so you can see this a little bit better. I'm not sure what we got there, but we got something. Okay, let's take a closer look at the scope here. I don't know what to say about this. I'm not going to say too much just yet. Let's fool around. We're going to tune the radio itself here and see what happens. Okay, so I'm off the signal. Ooh, let me put on the headphones and listen here too. You can listen to this. Okay, and I'll tune it back in. So I just tune right through to the other side. So I'm curious about a couple things. One is that line that's in the middle of the display here. What is that doing there? Not exactly sure. And remember, this is not a regular trace. This is going out and coming back, going out and coming back, right? It's not, there's no blanking. Let me turn this down a little bit. You just barely hear me, okay? What other things can I fool with? I can increase and decrease. I'll decrease the deviation. Kind of interesting. And so that noise you hear is when the deviation goes greater than 75 kilocycles. Either a limit of my generator or the radio. But it shouldn't go above 75 normally. So I'm going to put it back. It's around 60 or so. 60 kilohertz of deviation in the FM signal. What else can I do? Oh, I can move the signal around a little bit. This is tuning the generator. The same thing as tuning the radio, just the other way around. You would expect things to be quite... As you go through it, you expect what you see on the left to be the same as what you see on the right. You know what I mean? It should be like a balance or a symmetrical thing. Let's roll through it here. Well, I can hear this thing picking up some signal. Okay, here we go. Rolling through. Way off the top. But it never goes way off the bottom. So I would say it's not balanced, and that's not surprising. So there's a little room for some adjustments. This is 400 hertz, 1000 hertz, 5 kilohertz, well 19 kilohertz, which doesn't count. So it's certainly producing frequencies fine. Okay, we'll switch to sweep here. Now this is probably nonsensical. What's here? Not sure we need to listen to this, so I'm going to turn the sound down. That's the 60 hertz wobble happening. Okay, we'll tune the radio a little bit. You see lots of weird stuff going on there. How am I supposed to, I'm supposed to look at that and somehow sort something out. Oh, it looks like you're having a heart attack right at this moment. Well, that's off station. Or off signal. Wow, it's just a schmozzly looking mess. What do you make of that? What do you make of that? And that's where I'm going to leave it today, because this is right now where I'm ready to start doing some kind of alignment thing if I can figure out what's really going on here. Okay, that's good for today. So, thanks a lot for watching. Tomorrow I will... I'm knocking everything over today. You know what happened when the camera wasn't on? I knocked over a box of about 30, maybe 25 1930s vacuum tubes off. I knocked them. They fell about a good 3 feet onto a ceramic floor and just splayed out all over the floor. Not one of them broke. I couldn't believe it. And so that happened today. Goodness knows what happened inside those tubes, because they hit the floor hard. And that's enough babbling, I think. Yeah, that's enough babbling. Thanks a lot for watching, and tomorrow we'll try to seriously get some kind of alignment activity going here. Okay, see ya.